right. When you're measuring in glassware, you always have to look for the meniscus, and that's this curved shape, the bowl shape on the top of the liquid inside some glass measuring device. That bowl or curved shape is called the meniscus, and you're always going to measure from the bottom of the meniscus. That is to say, you're going to find the bottom of that bowl and find out and estimate what that measurement is on the side of the glassware. The glassware needs to be perfectly vertical. Now, the best way to make sure the glassware is perfectly vertical is to either clamp it in a clamp on a ring stand, or set it on the lab table. In the case of a graduated cylinder, you can sit it on the lab table and it'll stand perfectly vertical. Okay? Then your eyes need to be horizontal to that glassware so you can read it properly. If your eyes are not horizontal, you will read too much or too little liquid. Okay? So to get good measurements with liquids and glassware, you have to be able to do all of those things. All right? Any questions so far? All right then. Let's take a look at that. Yeah, how about that? Imagine that. Okay. All right. So the glassware needs to be perfectly vertical. All right. And when you read what's inside there, you need to make sure your eyes are perfectly horizontal to that, the way that I'm doing it here. Okay? And you need to be very, very careful about getting a good measurement at the bottom of the meniscus. Okay? If you don't do good measurements, that's your grade. Okay? You have to make sure that you're doing a good job so that your grade is good.
Is that glass?
Yes, it's made of glass. Yeah, if I drop it, it will not be good.
Okay, so I thought you said it was like a dip. Keeping the water.
I don't have any liquid in there right now.
I mean,
This one.
I understand that.
Huh?
I mean, you said it has to be perfect. Well, if there's a dip, how do you know if it's perfect?
Well, what I'm saying is your eyes have to be perfectly horizontal, and the glassware has to be perfectly vertical. Then when you look at where the meniscus is, because the meniscus is in the middle of this. So if you're looking down on it from above, it's going to look like it actually has more volume than it's supposed to. If you're looking up at it, it's going to look like you have too little volume. So in order to get the right volume measurement for the way that glassware is calibrated, you have to look at it in a perfectly horizontal way. That is to say, your eyes have to be on a line that is 90 degrees to the side of the glassware. Does that make sense? Okay? Now that might mean you're going to have to squat down a little bit or kneel down on one knee or something. But good measurements mean that that's what you're going to have to do. Okay? If you want to do sloppy work, you're going to get the grade that you deserve. All right? I'm trying to help you to get the best grade you can, and when you go to college, whether that's a 2-year college or a community college or a 4-year college, those are the kind of skills you're going to need and things you're going to be doing. Okay? I've done a lot of things, manual labor kind of things. I've done welding and electrical work and things like that, and those kind of skills are important to know how to do. Huh? I can weld. Yes. All right. Any questions about that? So tomorrow, that's one of the things we want to practice, is to make good measurements in glassware. We'll be using graduated cylinders. Okay, and you have to find the meniscus. You have to measure the meniscus. Okay? So let's look at this one here that I have written out here. I want you to write down on your paper what you think the measurement is for where this liquid level is. So here's 25 and here's 24 down here. What is that measurement? What is the amount of liquid? Write down what you think the measurement is.
Was that a line there?
I just drew a little line there to show you that you're supposed to be looking at the bottom of the meniscus here.
Oh, so one of the line going down wasn't there?
Yeah, I had all this here in the beginning.
Well, I'm saying that. Okay, you see those little arrows?
Here, these lines here?
Yeah.
Well,
That was not where the arrow is. That was not one of those lines.
that's not one of those lines. That's just there to show you where the liquid is. That's right. Let me take that out. Would that help you?
I mean, either way, I'm going to know.
White out. What are we doing?
Counter.
Get busy.
You be back?
Oh. Hello? Hello?
Yes. Okay. Yeah, well, that's not going to draw on it very good, so you guys have to do the best you can. I've got the meniscus down here like this. Okay?
I thought I didn't need it if I got this.
I'm not writing this for you.
Oh, excuse me.
Master. All right. Now I want you to turn to a partner quietly, discuss your measurement, and see if you got the same measurement. And if not, try to figure out why not. All the notes? Let's see.
I got what you got. Right. What you got? What you got right there? Oh, okay. I got what you got right there.
You might not need your book bag.
He said, you need to take my stuff. You didn't answer.
Huh?
He said that I need to take my stuff.
Oh, I'm sorry. I didn't hear the question. Hang on one second, okay? All right. Anybody still discussing? Dr. Drummond. She's in the guidance office. Everybody get that?
How you
You got it?
I got that.
I was 2 points behind. How you get that?
Okay. Well, this is 24, and this is 25. So each of these markings must be a tenth. 24.1, 24.2, 24.3, 24.4, 24.5. And then we're going to estimate the last digit in between. Okay? And I'm saying, well, it's more than halfway between 24.4 and 24.5. So it's got to be greater than 24.45. What?
How is it more than halfway? From that black line.
Between here and here, it's more than halfway. Well, let's put this marking on here like this. Let's see. All right. More than halfway up, right. And so if I put this on here, it actually looks like it's more like 24.46. Well, I would accept 24.48. That's acceptable. Remember, this is, listen, this is an estimate. It simply has to be reasonable. Okay? Would you say it would be reasonable to say that's 24.42? No, because it's way more. 42's got to be down here somewhere. So what we're looking for is a reasonable estimate. Yes, 24.47 or 46 or 48, those are reasonable. Okay? Does that make sense? No.
Can you go over how you got the whole answer again?
Sure. Here's 24, and here's 25, and it says it's milliliters we're marking here. Okay? So what we have to do is figure out, well, where is it between 24 and 25, because there's no numbers here. Well, there are 10 of these things. Everything in a science class would be on the metric system, so it's always split in tenths, right? So that makes this 24.1, 24.2, 24.3, 24.4, 24.5. If I, okay?
I think what I did, because I had 24.45.
Say again?
I had 24.45, but I didn't know how I got it. I mean, I didn't remember how I got it.
Okay.
Now I know.
Does it make more sense to you now?
Yeah.
Okay. Is there anybody else who needs me to go over anything? Does it make more sense to all of you now? Okay, you have to estimate the last digit, and that's from this point forward. If in any lab, is everybody listening?
Yes.
If in any lab you fail to reasonably estimate the final digit when using an analog device, you will lose points. Okay? If in any lab, if you fail to estimate the final digit when using an analog device, you will lose points. Yes?
How many points away can it be, like one up or one down, or can it be like...
Really, it depends on the device, because some devices, like, let's look at this measurement device here, okay? I've got really tiny markings on this, okay? It might be harder to get a good estimate with something as small a marking as that, okay? Whereas something with larger markings, I bet you could get it easier. Estimates can be easier to come by. So it would depend on the device, okay? So with a graduated cylinder like that big one I was showing you a moment ago, I'd expect a pretty good estimate, But if you were using a different device that had really, really tiny markings, such as a buret, which I haven't shown you yet, which are really tiny markings, then I would give you more leeway. Okay, that's what I mean by reasonable. Okay? Any other questions? That's a good question, by the way. A very thoughtful question. All right? Anything else? All right, so tomorrow, you guys are going to be determining the density of water at different temperatures. Each lab group is going to have a different temperature water, and then we're going to compare everything on a graph, because one of the things you have to do in this unit is be able to interpret graphs. So we're going to use that as a chance to practice math, the kind of math you've learned in this unit already, and to start interpreting graphs. Okay?
I'm not like good at graphs at all.
Huh?
I'm not good at graphs at all.
Well, hopefully you're going to get a lot better in this class, because you really need that in here. Okay? All right. So, since we're kind of on that subject, let's talk about graphs a little bit.